In this video, we're going to talk about something called the average value of the function. And the average value of the function, conceptually, is asking about this. We have the function f of x, which is doing something over the interval a to b. And that function has got some area trapped underneath it. Let's call this capital A for area. Imagine taking this area, this volume of maybe Play-Doh or silly putty, and flattening it out, smoothing it out, so that instead of having a curvy top, it has just a flat top. Imagine smoothing that area out so that it had a flat top instead of a curvy one. The question is, what y value would you have here to make the area bounded by this rectangle the same as the area bounded by this curve f of x from a to b? That y value is the average value of f of x, average value. And it can be found by doing the following. On the one hand, the area underneath the curve f of x is equal to the average value, that y, times b minus a. So this is height of rectangle times width of rectangle. But on the other hand, we also know that the area described here in this picture is given by the integral from a to b of f of x. Therefore, and here's the big takeaway, average value is given by 1 over b minus a times the integral from a to b of the function. This is what you want right here, this formula for the average value of a function. So let's use that formula in this next exercise. Calculate the average value of f of x equals e to the 2x on the interval from 0 to 1. And actually, I'm going to go ahead and make an executive override. Let's do this on an interval from 0 to 2. So what I will do is I will go ahead and set up the integral from 0 to 2 of the function e to the 2x. Then I'm going to divide that by the width of the interval in this problem, 2 minus 0. So I have 1/2, and then let's go ahead and calculate this definite integral, beginning by finding our favorite antiderivative, e to the 2x, and then dividing by 2 to counteract the 2 that would appear from chain rule if I were to take the derivative, evaluated from 0 to 2. Now if I plug 2 into this expression, I'll get e to the power 4 over 2. And if I plug 0 into this expression, I'll get e to the power 0 over 2. Now this cannot be simplified greatly, but if you like, you can use the fact that e to the power 0 is 1 and write your answer in the following format. 1/2 times e to the 4 over 2 minus 1 over 2 is the average value of this function on the given interval.